Hi, good afternoon, everyone. My name is Simon from Chemical Engineering Department. Today, I will talk about the effects of porous structure development and ash on the steam gasification reactivity of biochar residues from commercial gasifier at different temperatures. I have divided my talk into the following parts. Firstly, a short introduction and the aim of the study, followed by the sample information and experiment setup. After that, the surface area, pore size distribution, and ash content effect on char reactivity were discussed. The final part is a summary and outlook. As we all know, biomass is an important renewable energy. Steam gasification is an attractive technology that can achieve high efficiency towards hydrogen production. Moreover, the char conversion is a rate-determining step in the efficient conversion of biomass. And for the char conversion, it can be affected by different parameters. For example, temperature, particle size, gasification agent, and char reactivity. At present, the relation between the char carbon structure and the reactivity are mainly based on the like cold char or the char derived from the TGA. And also the study combined the effects of ash, also the char structure are very limited. And however, the mechanic studies on both parameters contribute to the char reactivity of real biochar. Biochar are important to enable to develop the kinetic model. Therefore, in this study, we developed of the porous structure of wood-derived char, structure effect on the apparent reactivity, and the ash content on reactivity. Now we come to the experiment approach. In this study, the char was collected from the entrained flow gasifier. And the original char looks like in the figure, shows like here. And the proximate analysis and ultimate analysis for the reference biomass wood and the original char are shown in this table. We can see the ash content is quite low for the biomass, which is only 0.3%. But after the gasification and the original char, the ash is like higher, much higher, and we can see it contains a lot of calcium and some amount of potassium. The experiment setup. So the steam gasification experiments were carried out in the TGA. And in each experiment, it's around 30 milligram of the sample were used. And it will heat it up into the required temperature, which is 700, 750, and 800. And also, the leached char sample were also prepared to check the ash content effect on the reactivity. The solution was used the deionized water. Now is the results and discussion. This slide shows the surface area effects on char reactivity. We can see in the figure A, with the increase of the conversion, the total surface area increase first and then starts to decrease, which around 70% conversion. For the figure B, it shows the micro surface area increase like all the time, up to 85%. And the ratio between the micropore and the total surface area, it decrease and then start to increase. And also we can see for all three different temperatures, like the trend are very similar. So the temperature has a minor effects on char pore structure development. In this slide, it shows the pore size distribution when the steam gasification at 800 degree. So we can see with the increase of conversion, the total volume, we can also see from the figure, gradually increase up to 70% and then start to decrease into 0.65. For the micro volume, it continuously increase. But for 70% and 85, it's almost the same. There's no like decreasing compared with the total pore volume. It's also similar result for 700 and 750, which I didn't show in the slide here. And also the morphology of the char converted at different, stopped at different conversions were also checked. So we can see for the original sample without conversion, it's not as porous as the one after converted up to different conversions. So we can see the honeycomb-like structures are observed, which means the new pores are formed. And also we can see there are some minerals accumulate together that might due to the higher, for example, higher conversion, the char converted and the more minerals can be easily like attached with each other, especially for calcium. And after for the investigate for the original char, the leached char were also conducted. Firstly, we leached the char for like 2 hours and 48 hours. And then we checked for the pore structure. It shows the structure are the same. And for the leached char, the surface area increased a little bit, which is reasonable. That's because of the mineral on the surface like was leached out. So we can say the leaching solution here does not influence the pore structure. Also, the ICP SFMS analysis were conducted for 3 samples. We can see that for all those 3 different samples, the significant reduction is the potassium, and the calcium and the magnesium are only slightly decreased. So for the further reactivity effect study, we will only consider potassium here. And this slide shows the effects of ash content on char conversion. So we can see with the increase of the conversion, the reactivity slowly decrease and then suddenly start to increase based on the potassium content here. We can also see for 48-hour leached char, the reactivity decrease like much sharp compared with the original char. We can conclude the potassium on the char surface can keep the char reactivity decreasing slowly. And also up to the twist point, potassium is a very important parameter to predict the steam gasification. And now we move to the summary and outlook. So based on the study, we summarize in this way, like with the higher conversion than 70%, the potassium affects more on the reactivity. But when it's lower than 70%, the char structure are more dominant. Also, the temperature has a minor effect on the pore structure development. And now is the outlook. So for the other types of the chars will also be investigated. And then the kinetic model will be developed based on the woody char residues. Okay, This is all for today. Thank you for your attention.